Hi everyone, let's look at this tricky question on rational expression. We are given that if x is to y is equal to 4 is to 3, what will be the value of this rational expression x squared plus y squared all over 2x squared minus 3y squared? What is the value? Knowing that x is to y is equal to 4 is to 3. It is tricky because we need to first of all have the right interpretation of ratios. X is to y, what is the meaning? 4 is to 3, what is the meaning in terms of rational expressions? The moment we get that, then we will now proceed to convert this other rational expression in terms of x all over y. All right, let's start. The first thing, x is to y, it means x all over y as a rational expression. Also, 4 is to 3 means 4 all over 3. Now, these two now make us to conclude that x to y equals 4 is to 3 simply means that x all over y is equal to 4 all over 3. That's our first information that we have from this question. So what we need to do now is to convert the rational expression x squared plus y squared all over 2x squared minus 3y squared into a new form where we'll be having x all over y. How do we do that? All right, that's the challenge. So reasoning it out, we'll see that we will be able to transform this into a new expression having x all over y everywhere if we simply divide each term in this expression by the highest power of y. Since y is at the denominator, we divide by highest power of y, and the highest power of y in this expression is y squared. So we're going to divide each term, x squared, y squared, x squared, y squared, each of them by y squared. So that we'll end up having an expressions in terms of x all over y. That's the only reasoning. Now let's go ahead and do that and see. Let's do that and see. We'll divide the first one, x squared all over y squared, this one, plus y squared all over y squared. This goes to the numerator. And then at the denominator, 2 into x squared all over y squared minus 3 into y squared all over y squared. All right, so mathematically speaking, this expression is exactly this. We have not changed anything because we have simply divided each term by the same expression y squared. So it's exactly the same. We should not make the error. Let me just go back there because some people will come here and then they will say x squared cancel x squared, y squared cancel y squared. That is not allowed. Why? Because we have the operation addition, subtraction. If on the other hand, we instead had but multiplication, if we had but multiplication, separating the two expressions at the numerator and the denominator, if we had but multiplication, then cancellation will be possible. We will now say x squared cancel x squared, y squared cancel y squared, so that we'll end up with 1 all over 6. That will be possible when the operation separating the two expressions is multiplication. But if it is addition or subtraction, we don't carry out that type of cancellation. We should take note. Now let's continue with our solution. Now this gives us, we see we have x squared all over y squared, this one. Here we have y squared cancels y squared, so we have 1 all over 2 into x squared all over y squared minus y squared cancel y squared minus 3. Okay, so this is what we get. Now, what is this? We know that x squared all over y squared can be written simply as x squared all over y squared can be written simply as x all over y, all of that squared, all right, plus 1 for the numerator. then divided by, we take the denominator 2, we do the same thing, x squared all over y squared can be written as x all over y all of that squared minus 3. Okay, all right, now we have succeeded to bring in the expression x all over y both at the numerator and at the denominator. So what is left now is just to put the value of x all over y, and then we carry out our simplification further with just figures now. X all over y is 4 all over 3. So wherever I have x all over y, we're going to put 4 all over 3. Now let's start. We have here x all over y squared. That should be 4 all over 3 squared. All right, that gives us 16 all over 9. So this numerator will become 16 all over 9 plus 1. All right, we can write 1 also as a fraction by putting 1 all over 1, so that we can evaluate that. The LCM is 9. 9 divided by 9 is 1. 1 times 16. 16. 9 divided by 1 is 9 times 1 is 9. So this gives us 25 all over 9. If we think that the denominator, this is the denominator, we have 2 into 4 all over 3 squared. This is 2 into 16 all over 9. That should give us 2 multiplied to 16, 32, 32 all over 9. Again, we should be careful with such expressions. These 2 multiplies by to the numerator. It does not come and multiply also with the denominator. No. Since this is a fraction, we can also write this as a fraction as that, so that we can see clearly that it is a fraction multiplied to a fraction. And whenever we have a fraction multiplied to a fraction, if the cancellation is not possible, then we simply say numerator go with the numerator. So say numerator multiplied to numerator, which is what we get, and denominator multiplied to denominator, which is what we get. Don't make the error to come and multiply up and then take this and multiply again down. All right, that taking note of. So we now have the numerator, it was this. Then we now subtract 3 minus 3. We can also write it as a fraction. This one is not clear. Let's write it down here. So we now have 32 all over 9 minus 3. We are expressing this. We are evaluating this. Okay, so since this is a fraction, we should also make this to be a fraction. 3 all over 1 is the same as 3. Now let us evaluate. LCM is 9. 9 divided by 9 is 1. Multiplied to 32 is 32. 9 divided by 1 is 9. Multiplied to 3 is 27. Okay, so this gives us 32 minus 27 is 5. 32 minus 27 is 5. So we have 5 all over 9. Okay, so we are saying that this expression divided by this will now be 25 all over 9 divided by 5 all over 9. Okay, this one gave us 25 all over 9. This one has given us 5 all over 9. So that we end up now with 25 all over 9 divided by 5 all over 9. This is a fraction. We maintain the first fraction. 25 all over 9. Convert this to multiplication and invert the other one. So that 9 cancels there. 5 here 1, 5 here 5. So that our final answer is 5. Okay? So that expression over there, this rational expression, with this knowledge that x is to y is 4 is to 3, gives us 5.